Hi everyone, and welcome to this webinar brought to you by the Information Lab. Here at the Information Lab, we dedicate ourselves to helping people make sense of data using Tableau and Alteryx. You're here with Adi, bringing you the third episode in our Spatial Essentials series. In this selection of webinars, we'll be focused primarily on the application of spatial analytics and locational intelligence for local government and public health. If you're looking for episode 1, click the link on the screen now to go watch it and come back here whenever you're ready. In this series, you'll probably notice a little overlap with our location intelligence in Tableau videos. Here though, we'll do the equivalent work and more in Alteryx. Now, the examples we use are skewed towards public health application, but even if that isn't your industry, do stay tuned. The fundamental principles are absolutely transferable to any organization looking to add value through their geographic data. Those fundamental principles being where things are and establishing location, how many things are where and dealing with spatial aggregation, and what is close, dealing with proximity analysis. The technical specs for adding value. I'm here using Tableau 2020.1 and Alteryx version 2019.4. If you look in the description box of this video, you'll see a link to a file share location where you can find all the data and starter workbooks that I'm using right here. And that file share location takes you to a zip file, so remember to hit right click and extract, perhaps onto your desktop, before you start using those materials. It's going to be great practice to follow along with me, so do join in, keep me company. Today we're going to dive into what happens when we want to move on from establishing where individual items are to figuring out how many items we have in particular locations. Answering questions like, how many existing customers do I have in this region? How many stores do I have in this city? How many GP surgeries are in this London borough? Now, in order to answer questions like these, we need to think about how we group or aggregate spatial data. And there are some very particular issues we need to be aware of when we aggregate. So we'll take a look at those and we'll then move into appropriate techniques for displaying aggregated spatial data in Tableau. Two really useful mapping techniques for displaying that data are proportional circles and choropleth maps, also known as filled maps in Tableau. And again, before we go into these, we need to cover off a little of the fundamental spatial principles involved in aggregation. Now, you may have heard elsewhere that all charts lie, and this is true. Maps are a form of chart, therefore all maps lie. Any aggregation that we perform moves us away from the picture of the raw data in some way. This is inevitable. So it's crucial that we attempt, as far as possible, to mitigate any misleading effects of aggregation. And if we aren't able to do that in full, we've got to at least share the caveats with our end users. Now, one of the key misleading elements is evident in something called the modifiable aerial unit problem, often known by the acronym MAUP. Now, this is a big issue. It's the subject of journals, of academic debate. But for this webinar, I'll aim to break it down as simply as possible. And for me, it comes down to this. When trying to figure out how many objects we have in a particular area, we can very easily manipulate the answer to that question without altering the data itself. Either knowingly or not, purely by our visualization choices, we can emphasize or minimize. That's the crux of it. Now, here's a bit more, and I'll show you some examples to consider. With the modifiable aerial unit problem, the MAUP, we get something called scale and zoning effects. The scale effect relates to the size of the areas that we use to aggregate or group up our data. And the zoning effect relates to the exact way in which the boundaries of those areas are drawn. If we make changes to either size or shape, of the areas that we draw will bring about changes in the apparent geographical distribution of the variables that we're looking at. And that would be a product of the visualization choice, not the underlying data. While we typically see the scale effect more regularly in mapping, it's really important to be aware of both. And we can see how they work in these examples. In the first, we've got the population aged under 5 in Alabama. And the data on the screen is data from the United States Census. Census data is collected at the household level. So if we use the underlying data, the raw data, we'd be trying to show about 1.7 million points on the map because Alabama has about 1.7 million individual households. In order to simplify the view and allow a user to compare values in space, we've aggregated that data to areas. Census tracts on the left and counties on the right, counties being the larger area. Now, aggregation or grouping into larger areas involves more pronounced averaging, and that acts to smooth out the underlying data points. And that can give a false impression of sameness in the area we're looking at. We effectively lose important spatial information if we aggregate to too large a region. We lose the variation that is inside the area we've chosen. You can see that if you look to compare census tracts with counties. Now, in the zoning effect, we have exactly the same number of points in each of these images, and they are in exactly the same place in each image. But we get a different aggregated total of dots depending on the way we draw our boundaries. Look at each picture. The dot positions haven't changed, but the total aggregation number for each of the zones, that number does change. So depending on how we draw the area, we might get the appearance of high values, of low values, or a smoothed combination of both. And again, that's not about changes in the underlying data. It's an artifact of the visualization technique. Now, for those of you interested in US politics, this zoning effect, this is at the heart of redistricting. It effectively allows gerrymandering to take place. Now, in reality, and moving back to our content here, any space on Earth can be divided in an almost infinite number of ways. And in order for us to move our analysis forward, we're going to have to pick one. You might be in a situation where the decision about what to do, which areas to pick for aggregation, are not your own. But either way, it's crucial to keep in mind that any pattern we see in a map may be as much a reflection of the choice of our boundaries rather than the underlying data itself. So with that in mind, let's actually draw some maps. I'm going to open up Tableau here, and I've got data that I've been using throughout this Spatial Essentials course, and I've got that open, the traffic monitoring stations data. If you need a second to open your own version of Tableau and get the data ready to follow along, feel free to hit pause on this recording, jump back in when you're ready. Well, we're going to keep going with proportional circles. Again, we've returned to the traffic station example that we've had in previous episodes of this series. Here in the view, I have 1,012 marks representing the precise locations of traffic monitoring stations across London. The unique location ID that you can see in the detail identifies each monitoring station. In the measures, I also have fields that refer to the number of vehicles passing by those stations in a certain year. I can size the marks in the view by the counts of particular vehicles, and that's going to enrich my map. So I'm going to do that, and I'm going to do that for HGVs or heavy goods vehicles. So if I drag this measure, place it onto size, I'm creating a proportional circles map. I'm aggregating data to previously defined point locations, and I'm using size as a way to help the viewer compare the significance of those locations. In this case, it's the number of HGVs passing each station. Now watch also how I can adjust the size to make things more clear to my viewer. First, using the size in the marks card, I can shift this to make it bigger or smaller. And also if we move all the way across the right-hand side of the screen, we can edit the sizes in this menu too. Now what we get when we have this view is we start to see the significance of particular trade routes throughout London. You start to see the prominence of this kind of arc in the north of London that represents quite an important route of the North Circular. You also start to see the large counts that are evident across the M25 with our heavy goods vehicles. And we also are able to identify those main arterial routes running east-west across the city. Now, at this stage, this might serve my purpose, and I might be able to say everything that I need to say about my data. But I might also be thinking that I want to reduce the number of marks in the view, so it's perhaps easier to digest, easier to look at, perhaps remove some clutter if I can. So all I'm going to do here is replace the unique ID with the location name field. So I'll grab location name from the dimensions, and if I drop that right over the top of location ID, that's just going to replace it in the view. Okay, great. Now this aggregates the stations to a less granular level, and it's showing us the number of HGVs we have at each borough. That's what the location name is representing. So although we simplified the view, you can see that we've lost the granularity of exactly where each station is. And really what this tells us is there's always going to be a decision to be made about the extent to which we can aggregate. We'll have to decide what loss of detail is acceptable to us for each scenario that we're looking at. Now, if you'd like to try this out at home, we're going to make another proportional circle map using the world indicators dataset that comes built in with Tableau. First off, let's move into a new worksheet, and you can see that I've named mine already. Prop circles, world indicators, so I'm going to move into this one. You can pause the video if you'd like a second to rename your worksheet, perhaps add a little bit of color. And again, we want the world indicators data set. Now I have this data already in my workbook. A reminder of how you add it to yours. You just roll up to this plus icon by the cylinder to add, connect to new data. And as I mentioned, the world indicators dataset comes with Tableau. So it will appear as your saved data sources. What you want to do is give that a click to add it in. And you'll see that we get something like this. Now, someone has taken the time to organize all the fields here very neatly into folders. And that's worth doing if you have many dimensions or measures. You group them all into kind of like folders. If you want to do that yourself, I've dropped a link in the description to a great blog on how to do it if you're not sure how to get started. Well, back to what we've got here. If you take a look at the fields that there are, especially in the dimensions, notice what's been identified by Tableau with the globe fields in blue. And remember from previous episodes that this means Tableau is using its internal geocoding engine, its internal reference sheet to identify those countries, to generate for those countries a latitude and a longitude. And that means that when we double click the country or the region field, we'll be able to see those countries or regions come up on a map. Now, what I'd like you to try to do if you're looking for a challenge at home is build for me a map that's going to show the total CO2 carbon dioxide emissions at the country level for 2010. So the year 2010, that's the last year where we have complete data for CO2. And I'd like you to do that using proportional circles. And you're going to give me something that looks a little like this. Now, don't worry about matching the color palette that I've used. You're just looking to have proportional circles for CO2 for the year 2010. If you want to try that out yourself, hit pause in the video now. If you're staying with me or you've just come back, welcome back. Let's go through this. Let's get a solution. Again, CO2 emissions for each country for the year 2010. Let's go into my solution worksheet. I've got my world indicators data. All I'm going to do is double click on the country region field, and that brings those into the view. You can see that by default it's giving me circles already. Now what I need to do is size those according to CO2 emissions. So I'm going to pull CO2 onto size. And I also identified that I wanted for the year 2010. So I right click and drag year onto filters. I click on years because I want to select out one of those years. And I want 2010. So I'll click OK. And here we go. Now, all I'm going to do is just adjust the sizes a little bit more by dragging the slider. And going back, I'll turn my border off and I'll go for my favorite kind of burgundy color. Here we go. And this is looking pretty much the same as what we set out to build. So we have a proportional circles map for 2010 for the CO2 emissions for each country. Brilliant. Well done if you got there. Now with this technique, we might run into some issues with a large number of locations or when we have circles that begin to overlap. The overlap, we can use some adjustments in color to help us. Perhaps we can alter the opacity here. So I'll just shift this down maybe to 80%-ish to start with. And that gives us a little bit more to play with. Now, proportional circles are a great way to display the unadulterated raw data that we have. It's a great way to show totals. And we can use them at the global level, as I've done here. And notice again that the aggregation to the country level means that we do lose any internal variation in emissions, in this case, within countries. You can see that we get only one dot per country, so we can't see any internal variation. But we can also implement proportional circles equally well for totals in raw data subnationally, as you saw me do with the traffic monitoring station data. And we're playing off the user's ability to gauge the size of a shape in order to assess what is less or more. So identifying variation in space. Now the second technique that we talked about, the choropleth or the filled map, what we're looking for is to put a metric on color rather than size. But again, by doing that, we're getting the variation in a metric through space. A filled map, a choropleth map, should allow us to compare values between one place and another. Filled maps are incredibly valuable when we have raw data that's tied to specific spatial units, like census areas, counties, provinces, states, for example. However, they're also a very recognizable form of data visualization. And because of that reason, they're often implemented for other purposes like crime, disease mapping, pollution mapping, showing emissions, as we're doing here. And for those cases, the raw data doesn't respect arbitrary administrative units. Think about pollution, perhaps. It doesn't just stop or change at the border between Canada and the United States. The underlying data don't work like that. And at this point, it would be incredibly useful for you to take a little 20-minute break from me here in this video to watch one I recently shared with Tableau on responsible thematic mapping. If you click the card now on the screen and watch the first 20 or so minutes of that session, you'll really get to grips with the use and caveats of filled maps in Tableau. I'm going to continue here with the assumption that you have watched that session. Now, creating a filled map in Tableau. It's easily done with any of its default spatial areas, any of these native geographic roles that Tableau will recognize. And I can show you this using the CO2 data that we're looking at just now. I'm going to jump into a new worksheet. I've called that CO2 choropleth because I am building a choropleth or a filled map. I'm going to begin in exactly the same way. I'm going to double click my country region field, and that brings those dots onto the map. Again, I want CO2 emissions. So I'll drag CO2 into the view, but I'll place it on color this time rather than size. Okay, great. All I'm going to do is just float over this little kind of play icon, and that's going to bring me what looks like a compass, and that's going to allow me to pan my map just so I can get a sort of unbroken North America and Russia view. Perfect. Last up, we still want to identify 2010, so I'm going to drag the year onto filters, select years, I'm going to hit next, and again hit 2010 and apply this. All right, now here we have CO2 emissions per country for 2010. Now aesthetically, we're subjectively perhaps looking at a simpler map, a less cluttered map, one that many folks will be used to seeing. They may prefer seeing the data in this way. But this is where the danger is. Like, just because the map looks good or people are used to seeing it in this way, it doesn't mean that what we're showing is truthful. And here's the thing with any choropleth map, and you'll know this if you took that break to watch the other video I just referred to. For choropleth, for filled maps, we cannot plot the raw values alone. If we do that, we are telling lies to the audience. Now look at this example. And we see that China seems to be churning out the greatest CO2 emissions. And I'll show you that just by adding a label in. And I'll want my min-max labels. And I just want to label the maximum value. You can see that China is coming out. Let's make that a different color so we can see it a little better. Here we go. China, the maximum CO2 emissions by raw number. It has the max value. Now that might be something that you want to visualize. That's fine. Go for it. But this technique, the choropleth, the filled map, it is not the technique to do raw numbers. This mapping technique is designed to help people compare values through space and assess relative importance. If you want to show raw values, raw numbers, go for a table or revert to the proportional circles approach that we just created. Now here's why. Each area that we have on this map, each country, is a different size with a different population. China looks to emit a huge amount of CO2, but China also has more than a sixth of the entire world's population. And that population is clearly driving those CO2 emissions. So all we've done is create a map that really just approximates population. If we want to use the map to investigate how CO2 emissions vary in space from country to country, we need to create a standard baseline that will allow us to do that. Now, because CO2 is driven by industrialized populations, we're going to use population as that standard baseline. So let's create a CO2 emissions per person field by clicking in the top right caret in this data pane. I'm going to call this CO2 per capita because that's what we're creating. Again, what I want to do is start with the same metric. So I want CO2 emissions. Here we go. And I want per capita per person. So the per is the divide, and I have the total population as well in my population folder. So we'll put this in. Now to be sure that the aggregation is correct, We'll wrap each of those in a sum. So the total emissions divided by the total population for each country. And that gives me my CO2 per person metric. So we'll apply that. Now let's go ahead and remake the map. Now this time I'll just replace the original metric with my newly created one. So I'll drop it over the top on color. And I'll also just switch off my mark labels just for a sec. And let me go ahead and just change the colors to something that will make things a little more clear. And we'll just adjust that border ever so slightly. Okay, great. Now we get to see here how things have changed. China's significance in the map has dropped away, and instead we pick out, well, the United States still. Even corrected for population, its per capita emissions are large. Australia jumps into the mix. Australia is big into coal. Also, look at the Gulf states where the bulk of the world's oil comes from. We're now able to pick out their significance by using this adjusted metric, this per person metric. And we can say more accurately, more or less, because we have a standard baseline to compare each country. Now, you potentially notice that with this color palette, it's not doing a fantastic job at pulling out the smaller values. While we're able to see Australia, the United States, the Gulf states, the many other nations that we have are falling into the same kind of light blue or greeny color. So we're going to need to make another adjustment to this, because although we have the correct per capita metric now in the view, we still can't effectively compare the values in space. Now, I've taken the time to understand the underlying data and I've grouped it into bins and I've used that as the basis for a color palette. And I have that here in a notepad file, so I'm going to copy this across and use that instead to color the view. So I'm going to call a new calculation my color palette. And then what we're going to do is just navigate to my notepad where I have this created already. And we're just going to copy this back across into the Tableau view and paste it in. Here we go. And we have my color palette, so I'll just drag that onto color now. Perfect. This gives me the default colors, but I just have to go back in and select the one that I want. And I'm still going with this Makeover Monday sequential. To assign that color palette, let's apply. Alrighty. Now, what I want to do also is just get rid of any of those nation states where we don't have any data. So let me just duplicate that CO2 per capita. What we'll do is convert this to discrete. I'm going to put this on as a filter, and I want to exclude anything that's null. And let's apply that. Okay, that's what I was looking for. Okay, great. Now, this is useful because we're more easily able to see the United States, the Gulf states, Australia, but we also get a bit more subtle variation across the nation or the continent of Africa and also South America. So this works quite well. And now finally, because I'm assuming that you've watched that video that I did with Tableau on responsible field mapping that I referred to a few moments ago, you'll know that we really want to get out of this web Mercator projection when we use thematic maps that have an element of population attached to them. So the final step, ideally, that we would take in the creation of this CO2 carbon dioxide per capita map would be to reproject the base layer and create something like this instead, where the distortion in country area is minimal. Now, I'm not going to guide you through that procedure now, but there are links in the description box that take you to tutorials that are going to guide you in doing that. You'll see, if you watch the Tableau video, that it's incredibly important to get away from this default view of the world into something that's a little bit more like this. Now, so far, we've had a lot of information, a lot of good stuff on creating filled maps using some of the spatial units that Tableau natively recognizes: countries, states, regions. But what about the situations where we have our own custom areas that aren't recognized by Tableau's internal geocoding engine, where perhaps we need to read in a custom shapefile and we want to have a way of relating our spatially ready data to that custom shapefile? Well, the good news is that's where the new features from Tableau version 2019.2 come in. Until that release, we weren't able to gather latitude and longitude fields together into single geometry columns. But with the make point function, we can do this. And if we have geometry into different data sets, we can then relate them based on their position in space. This is effectively mimicking an intersection in the spatial match tool in Alteryx. It's not a join based on common name or value, but where two features share the same space in the world. And that's incredibly powerful to have directly in Tableau. And we are going to dive into this, and it's going to involve some steps for some of you folks that you won't have seen before. So do hit pause, rewind at any time if you need to see anything again. I'll be here with the next step absolutely when you're ready. So first up, I'm going to use my new worksheet here called Custom Coro Traf Borough. Brilliant name. Because I'm going to make a filled or a choropleth map of traffic counts at the London Borough level. So what I have here, my traffic monitoring stations. The first thing I'm going to do is duplicate that by right-clicking, hitting duplicate. I'm also going to right-click that and hit rename because I want to keep things nice and neat. And I'm going to call this Custom Coro Traffic. And that just helps to keep me right, minimizes any risk of me getting confused with where I've done what. Now, next up, again, let's take a look at the fields that we have. At the moment, we've got two fields representing geographic location. Latitude is one, longitude is the other. And to be able to relate these fields in space to a native spatial file, a shapefile, for example, we need to have one field, a geometry field. So we're going to make points. Now let's do that by clicking this caret up here, this drop down. I'm going to create a calculated field, and we're just going to call this station locations. And the function that I want, as I've said, is make point. Try and spell that right. And we know from the configuration of the make point tool, if we look over here, let's make this a little bit smaller so we can actually see it. If you look over here on the right hand side, it's returning to us a spatial object constructed first up from latitude and longitude. And that's what we have in our traffic stations dataset. So I can begin to type lat long in here, or I can drag them into the calculation. So I've got latitude, and then I'll drag up longitude and just pop it in there, apply, we'll okay that. So now I have a blue field for station locations, and I have spatially enabled this data source. This data source now has a single geometry column that will render points in the view. And once I've added my native spatial file, we're going to be able to get these to interact quite happily together. But with Tableau, we're not going to be able to join on this calculated field, but that's okay because we're just going to remake it in the join calculation. So let me go ahead and show you how I'm going to get this spatially ready file originally to talk to my spatially enabled London Borough file. So we're going to jump into our data source pane. And what I want to do is establish a connection between my traffic counts and my London Borough shapefile. So I'm going to add this, and you're going to want to hit Spatial File and navigate to your data sources folder from the downloaded content that you have for this course. The shape file, the .shp file that renders the shapes in the view, that's the one that we want. That's called London Borough, so we'll open that up. Now this is where we get some of the magic to happen. On the left-hand side, remember I said that we weren't going to be able to join on that calculated field, that we just have to retype it in the join calculation. So again, here I go, start to type, make point. I know that I create that calculation using lat and using longitude, and we'll OK that. And on the right-hand side, that is a natively spatial file, so it has a geometry field already. And once I have two geometry fields, I get a new option for my join condition. Not equal or more or less, but this spatial one, this intersects. And that's the one that I'm going to click. And what I'm going to say is, let's have all of my traffic stations. Let's go for a left join here. And then let's pop back in to my borough, my traffic borough map. Okay, now we're going to remake this map. And we want to identify the geometry field from the London boroughs because I want to aggregate the points up to the borough. So I'll double click the geometry. And these are the outlines of London boroughs. If I look up at my dimensions, I'm going to add the name of each borough to the detail, and that allows me to interact with each of these individually. Now what I want to do next is aggregate up the individual points for each traffic station to the boroughs. So I just want to sum up how many traffic stations I've got in each one. So I'm going to grab the unique identifier. I'm going to place that on count, and I'm right clicking here and dragging, and I'm going to ask to count the unique location ID for each borough. All right, great. So here I have the total number of traffic monitoring stations across London broken down by borough. And I have the greatest number of stations in the borough of Hillingdon. It's the darkest blue. Okay. Now note, as we've made this, that as yet we haven't standardized the data. We haven't created a baseline by which we can compare. So area is a problem here. Hillingdon is a big borough by area. So we could use the land area to standardize our counts. Really, it would be ideal if we could get the length of the roads within each borough instead. Now, we're not going to go and do that now, but be aware of the next steps that you need to complete when you're creating each of your field maps. And the steps that are probably new to you, they're more important to sort of go over just now. So we're going to do another example. And again, I'm into another worksheet. This time I'm calling it Custom Coro School Borough. You can potentially guess what's going to happen next. Is we're going to use the school location data set that we've had before, along with setting up a connection to the same London Borough shapefile that we've just used. So my school location data set I already have. Remember, if you need to add it, you want to go to the plus beside the cylinder. It's a text file, and it's in your data sources. It's this school location 2016 CSV file. I've already got that. Brilliant. Now, remember with the school locations that we have this X and Y named fields representing longitude and latitude. So to avoid any confusion, again, we're going to rename that our X field is longitude, and our Y field, let's right click and rename, that's latitude. Tableau still doesn't really know what we're up to, so we'll go right click, we'll change the geographic role, and we'll tell Tableau that we have a latitude here, and also a longitude is longitude. All right, nice. Now, what we're going to do again is just create points with these two fields. So we're going to gather the latitude, longitude together into one single geometry column. So we're going to move up to our caret at the top of the data pane, create a calculated field. Let's call this school locations. And we are back with the make point function. Remembering that we've just made the latitude, longitude field, so we can grab those in, or we can start typing and they're going to come up. And let's OK that. Brilliant. Now we have a single field that represents points that will be rendered on the screen for the school locations. And now we're ready to go back to our data source pane and establish a connection between our school locations and our London boroughs, purely based on their location in space. So I'll hit data source. I'm going to set up a new connection here on the left-hand side of the screen by clicking Add. I want to connect to a spatial file. It's the same one as before, London boroughs. I'm going to open that up. Now again, as I just did, we're going to need to use a join calculation. And the make point, spelt correctly, is the calculation that we want. Again, it's by latitude first and then longitude, which we just renamed. And we're going again, right-hand side. We want the geometry this time. Notice we now have an intersection that's available. And we're going to have, let's make sure we grab all the boroughs, even those that don't have any schools in, although they all should. So let's go for a full outer join this time. And let's jump back into the worksheet. Again, we set this up in exactly the same way. We're trying to show the boroughs first, just coloring those shapes by the number of schools that we have. So we're going to double click geometry. That gives us the boroughs. All I'm going to do is grab the borough name, put that onto detail, so I can interact with them all individually. Now next up, I want to count the number of schools in each borough. Each school is identified by its unique object ID, and that's currently a continuous measure. I just want to make that discrete because I want to count that aggregation rather than sum it up. So let's make that discrete. Let's pop that onto color. That's going to give us lots of different colors, but that's fine because I'm just going to right click that and I want to count. And let us get rid of this longitude field. So just going back one step, we've got a little misfire here in the data. So all I do is left click that and I want to filter the data here. So if that's what you're getting, just left click and filter on the location that's not being picked up. And this gives us the distribution of our schools across the different boroughs in London. Croydon, 159 schools. Up here, Barnet, 171. Perfect. Okay, that's job done here. Number of schools, boroughs in London, amazing. But you can see that although we've successfully completed this filled map, we have a difficulty in the aggregation, because if I very quickly create a dual axis map here and replace what I have with our school locations, you can see that we lose the granularity completely. We don't get to see the internal variation. We don't get to see the distribution of our schools or how densely they're packed. All we get is a very simple, highly aggregated view. So the follow-up question that we have is, do we have any other options to show a greater degree of granularity somewhere between showing every single point and this very highly aggregated view? And in this case, the answer is yes, because the London data store, where we sourced our borough shapefile, gives us the option to have LSOAs as well. That's lower super output areas. Now, if at this point you're feeling confident in the procedures that we've gone through, and you want to have a crack at this yourself, here's what I'd like you to try to create for me. I'm going to have a count of all the schools in each LSOA rather than each borough. Again, don't worry about the color scheme that I've used, but I've labeled Enfield 004C, that LSOA, to give you an idea of whether you've got it firing correctly or not. Again, that's in the data sources folder that you have. It's the LSOA shapefile. If you want to have a go, hit pause now. Come back again if you're ready. If you want to follow along or you join them back in, let's take a look at how we do it. All right, now what I'm going to do is duplicate my school location dataset. I'm going to rename it. Right click and rename. So let's call that LSOA solution. All right. Now you can see that I still have the join here with the borough, but that's okay. We'll go into the data source just by clicking it. Take that connection away. So let's remove that. I can leave my school's location with that connection set up, but I actually want it now to be connected to this LSOA 2011 file. If you don't see that in your connections, go to Add. Want to connect to a spatial file. You're going to go to your London shapes within your data sources folder, and you want this LSOA 2011 for London. Let's open that. All right, now it's just a case of going through again the same procedure of making points, of joining based on the geometry, that spatial intersection. So we want to make a point here. We have a latitude, we have a longitude. And let's OK that. And over on the LSOA side, again, we want geometry, we want to create an intersection. Here we go. And again, let's go for full order. We shouldn't have any schools that aren't in an LSOA, but we'll just make sure that we don't. Now this time, coming from the LSOA side, I want to plot the geometry. So I have about nearly 5,000 of these shapes on the screen, rather than the 33 that we had for the boroughs. Again, I'm going to interact with each of those individually, so I'm going to put the LSOA name on detail. Here we go. And what I want to do now is the same thing, to count and to color my map by the count of the number of schools that I have in each of those LSOAs. So if I right click and grab my object ID this time and drop it onto color. This will automatically bring up the required field that will let me pick the aggregation that I want. So I need to have a count here. And again, let's get rid of this misfiring. Null field, so you just want to filter that. Smash in. Now the rest is aesthetic. If we hover over end field, this is what we should be seeing. In my case, I'm going to get rid of the borders. So that's looking a little bit more like the challenge picture, if not exactly the same. If I just adjust the color, my color palette is this favorite Makeover Monday style. All right, here we have it. Now you can see that this is vastly different. We've got nearly 5,000 LSOAs in London, but we only have 33 boroughs. So if we aggregate up to borough, we lose everything within that. We lose all the variation, all the subtlety. And now we're doing better here because we've aggregated to a smaller area, so we've got some variation. But as before, we must still standardize the data in some way. And perhaps as we've gone through, you've noticed that in the LSOA shapefile, we have some fields in the measures called H hold res, H hold pop den, usual res. That is, or those are population fields, household residents, households, population density, usual residents. And we're going to use the usual residents field. Perhaps ideally we'd have the school age population standardized by, perhaps getting that from the UK census, but we don't have that just now, so usual residents is a good way to approximate that. Another caveat perhaps you're thinking of is that children don't always go to school in the same local area that they live, but again, for this example, it's acceptable for what we're doing, and this method is better than no method. So what we want to do, perform our standardization calculation. Click the caret in the data pane. Let's go to calculated field. And let's call this, we're going to go schools per 1,000 pop this time, because we want to do a per 1,000 correction. Now, as before when we did with the CO2, we want the metric that we have in the view first, which is the count of our object ID. That's what's in the view. And when we're correcting for weights, we have like a per person or per 1,000 person metric. The per, that's a divide. And we want to divide that by population. And the population field that I said that we would use, that's going to be usual residents. We want to make sure that we have the aggregation correct, so we're going to wrap that in a sum. Now, because the count, because the top line for this is going to be small, and the usual residents or population is going to be big, the outcome of this calculation is probably going to be something that's quite difficult for us to make sense of. So in these cases, not just for this type of metric, but also for things like disease mapping or anything really that you have population, you might be better just wrapping that in a bit of a correction. So we maybe have 1,000 times this or 100,000 times this. In this case, I'm going to go for 1,000. And here we go, schools per 1,000 population. Now this is corrected for the underlying population because each of the populations of our LSOAs are different. So we can see how that looks if we just plot those side by side. Excuse the sirens going past. At the minute, I've just created a dual axis map by holding down Control, left clicking, excuse me, making a little duplicate of longitude, and I get two columns with the same map. All I'm going to do now is just replace this metric that's currently on color with the schools per 1,000 population metric that I just created. So I'll drag that into the marks and just pop it over the object ID that's on color, and that will replace it. Okay, let's just standardize these colors as well. So we'll go away from the default into the sequential Makeover Monday palette. Okay, now again, we get something that looks quite different. As our per 1,000 population calculation, we have a different pattern coming into play completely. Now, we are now allowing a user to effectively compare across between LSOAs. And this is an incredibly valuable thing to do. So far, we've created choropleth maps, custom choropleth maps. We've performed a spatial join by intersecting two different geometries. We've standardized our data to allow users to effectively compare. Now, this is really good stuff. And we've done in previous episodes, we've gone into Alteryx to do some of the same operations there, and we're going to do that again today. And just to say that, for me, probably from a performance point of view, we potentially want to be pushing a lot of heavy lifting, the burden of processing into Alteryx or something like Tableau Prep, so that we're able to leave Tableau Desktop to do the visualization and exploration element. We allow Tableau to stay nimble and render our visualizations quickly. That's what our end users are really going to want to see. But all right, for now, we're into Alteryx. So let's open it up. Now we're going to use Alteryx to create a new data set here, as well as look at issues of aggregation. So go ahead and open starter workflow number 4 from your participant materials folder. That's number 4, process LDN GP practices, process London GP practices. Now pause the video if you need a second to find that workflow. Here you'll notice that I'm feeding in an Alteryx database, a YXDB, and it's a database of England and Wales GP practice location. The original data comes as a CSV that you can download from NHS Digital, and the link to do that is in the description. If you remember from previous episodes, the conversion from CSV to YXDB to Alteryx database is really about efficiency in processing. So I've done that conversion already for this workflow. If we look at what fields we have using the metadata tab, you'll see that I have a whole range of address details for our GP practices. You'll see that we're spatially ready because we have latitude, longitude fields, but we don't have a spatial object here, so we aren't spatially enabled. Remember, to do that, we need to gather the latitude and longitude fields into a single geometry column. In Tableau, that's with Make Point, and in Alteryx, that's with the Create Points tool. In this case, actually, we don't need to spatially enable this file at all. So if we take a look at what else we have in the GP data, we have the LSOA code. And if I bring in my LSOA shape file that I've been using in Tableau, having the input data, and again, I just navigate to the same place as before, my London shapes, and I want my LSOA 11 shape file. You can see here that the first field that I have is the LSOA 11 code, the same. And if I check up top with my objectives here, I want to first, number 1, identify only the GP practices in London. So although we have the option to perform a spatial match tool to siphon off London data, you remember the spatial match cookie cutter operation from the last episode, we can also just do a straight join here based on the LSOA code because it exists in both streams of the data. So we can proceed like this. We're going to bring in a join tool, and that's in the join ribbon, the purple one up here. Let me drag this join tool into the canvas. I'm going to hook up my YXDB to the left-hand side and my LSOAs to the right. And like I said, this join is based on the LSOA code. So we're going to scroll down, select the LSOA code on the left and the LSOA code on the right. At this point, I'm going to spend some time getting rid of some of the fields that I don't really want. And I'm starting at the bottom. I can left click, and if I hit Control and click in this square beside each of these columns, I can select multiple at once, and then I can just select or deselect them all. So I don't want households. I'm going to keep usual residents because that's the one that we're using for our calculation. I'm not going to take any of these other geographical identifiers. I just want to leave myself with the LSOA codes. And from the GP data, let's see, I'll keep the latitude, longitude. That's going to be important for later. Possibly the CCG. The LSOA for sure. The postcode, yes, probably, but let's get rid of some other elements of the address detail. Maybe just leave ourselves with the name of the organization and its unique ID. So you can see that I've got multiple fields highlighted here. What I want to do, go into options, I can switch all of these off. So deselect highlighted fields. Lovely. Now that stops me having to go through and click, click, click every one that I do or don't want. All right, now if I run this flow, I'm going to get those practices that are in London with an identifier of the LSOA that we're in. So if we run this, here we get out nearly 1,400 GP practices. If we just get a look at our results window, and if we scroll across, we get an identifier of the LSOA, the code that they're in. You also get the name, and we've brought through the usual residents in each of those LSOAs. And we've also brought through the shape, the polygon object for the LSOAs. So we could map these if we wanted to. But we have effectively ticked off number one, identified those practices from this entire database that are in London. Okay, success. Now for objective 2, I want to count the practices, the GP practices per LSOA. So all I'm looking to do is aggregate or group the data to the LSOA level. So I want to go from having a row per GP practice to having a row per LSOA with a count of all the GP practices in there. Really, I'm simplifying the data or summarizing the data. So that drives me to the tool that I need. It's the summary tool. And that's up here in the transform tool palette if you don't already have it in your favorites bar. So I click transform. I'm going to drag the summarize tool down here into the canvas and connect it up to the J anchor from my join tool. Now let's look at the configuration here. In my objectives, I want a count of the GP practices. They're identified by a unique ID. That's the UID field. So I'm going to ask Alteryx to count this field. And I want that count to be at the LSOA level. So I'm now going to ask Alteryx to group the count by the LSOA. So let's go ahead and do that. We have LSOA. So we'll click on that, and I want Alteryx, let's go for the code actually, I want Alteryx to group by that field. Now if I run the flow at this stage, this will technically give me the answer to objective number 2. I'll get a count of GP practices for each LSOA, a list. And for my purposes, for the analysis that I'm doing, that might be all I'm after. But if this is part of a larger project, I may also wish to push through the spatial objects for the LSOAs so I can maybe map them later on. In which case, I'd include that in the summary tool by also asking Alteryx to group by the spatial object field. But again, it depends on what your larger purpose is. That really should be what guides the analysis rather than the tool or the software that you're using. Remember, you're in charge. Now, for objective 3, we're thinking about heading off any potential issues with comparing spatial units, in this case the LSOAs, of different sizes and populations. As we did in Tableau, we want to standardize our output for population. If I run this now, you'll see that we just have that count of GP practices per LSOA. It's not standardized in any sense. But you remember that we do have population fields in the LSOA file. And the one we used in Tableau was the usual residence field, and that's the same one we're going to use just now. If we want to have that in our analysis coming out of the summary tool, we need to push that through the summary tool by making a selection in the configuration. Now, in the data, we have a single population value for each LSOA. If we summed that population, let's just take a look. So we have usual resident population. If we sum that value in the summary tool, we're going to get an incorrect value for the LSOAs that have more than one GP surgery in them. And what we actually want to do is to group by that value as well, so we only pull through the single total population for any LSOA. So let me demonstrate that, that difference by picking both of those options in the summary tool, like this. So we want the usual resident, so I'll click on that field. I'm going to add first, let me add the sum. Second, let me add a group by. And let's run this again and see what happens. Coming out of the summary tool, here you can see the sum of usual residents and the group by usual residents, that's the same, but only when the count of GP surgeries is 1. When the count is 2, we have double the normal population. When the count is 5, 5 times the normal population. So you can see what's happened. We have inflated values for total population. So let's go ahead and remove the incorrect value from the summary tool. I'm just going to click that summarize field. I'm going to click this minus sign to get rid of that. Okay, great. And we now have, or we will have, a usual residence field that we can use to standardize the data in order to get a rate of GP surgeries per 1,000 population. Now, to perform that standardization, we need to get a calculation on the go where we want to create a new field for rates. We need a formula tool to do that. You'll find the formula tool up here in the preparation, the blue preparation ribbon, if it isn't already in your favorites. Remember that each tool has got a star beside it, which you can click on if you want to add it into your favorites bar. It just makes it a little more easily accessible. Let's drag a formula tool down into the canvas and we'll connect that up to the output anchor from the summary tool. I'm going to set up our calculation. So in the configuration, we're going to create a new column. Let's call that rates per 1,000 population. And I want that potentially for later analysis, I want that to be decimal point values, numeric field. So let's change that up. And again, the way we set up the calculation, it's very similar, if not exactly the same syntax as in Tableau. We want our metric, our count in the top line, and that's coming out of the summary tool. And we want it per population, per unit population, and that in this case is the usual residence field. So I started typing that in. If you can't remember, just pop over here into the results window. You can see you've got this symbol for messages, you've got this symbol for input and one for output. If you click the input, that will show you what fields are coming in. So if you can't remember what you called something, you can refer to that. Here again, you see I have my count divided by my usual residence. And again, as I did before, that's going to give us a small number. And if we want something that's a bit more easily digestible, just going to wrap that all inside a multiply by 1,000 set of brackets. Now this is ready to run as it is. But at this stage, I'm thinking, hey, I'd like to get some order in the data. Perhaps I want to look at the highest rates per LSOA across all of London, or the lowest access to GPs for our population. And if I want to do that, all I need to do is use the sort tool on the data. And again, that is in the preparation tool window. They're in alphabetical order, so we're looking over to the right-hand side for S. I'm going to drag the sort tool down into the canvas. When I look at the configuration, I can put this in alphabetical order or sort it by the counts, but again, I want to sort by the rates. And first off, I probably want to see the highest access of the population to GP surgery. So I'm going to sort this descending, which will give me the highest to the lowest values. Now let's run this and see what happens. Okay, now, here again, I technically have the answer for objective number 3. I have the LSOA with the greatest number of GPs per 1,000 population. So our rates, we've got about 17 GP surgeries per 1,000 population. That seems good. If we scroll down, we could change the configuration and run the flow again, but if we scroll down, we go all the way to 0.3, so less than 1 GP surgery per 1,000 population for some of the LSOAs in London. Now, that might be the answer that I'm looking for, but here at the minute, with the LSOA code, it's just a mix of letter and numbers. To my mind, it's not easily understandable. It doesn't tell me anything about London. So really the LSOA name would probably help me out a bit more. And that is in the data. We just didn't bring it through in the summary tool. But that's absolutely fine. Like, Alteryx is flexible. We just return to the summary tool and make sure that we bring that through the tool. So if we scroll down, we already have the LSOA code. I'm saying that the LSOA name would be useful, so I'll click there on LSOA name, and I'm also going to group by that. Now, if I leave the tool configuration like this, the LSOA name is going to come in and sit as the last column beside the usual residence. Possibly just to make it easier to read, I'd put that beside the code. And in order to do that, just make sure I have the name field clicked in the summary tool configuration and use the arrow to shift it up slightly. So what we'll see is the name being the second column with the way I've configured this. And let's go again. Okay, great. Now this time I have a little bit more context about what's going on. You can see that the order hasn't changed. We have 17 per 1,000 GPs here. But instead of having this LSOA code that doesn't mean an awful lot, I now have a name. So Southwark, this is South London. Kensington and Chelsea, that's kind of central West London, as the next highest to the lowest. If we scroll down, out there, West London, Hillingdon, then Brent, Greenwich, with the lowest rate of access to GPs for the LSOA population. Now, again, at this stage, I'd be reflecting on the greater goals of my project here to think about what I need to do next. Now, whether that's export these results as they are, bring through the spatial object for the LSOA so that I can export the data and map them easily, or maybe I just need to continue with my Alteryx flow. Perhaps I need to supplement with other data or have other streams coming through. But for now, I fulfilled those three kind of basic objectives that I originally had when I was looking at these data. And with that, we've reached another natural break in the content of this Spatial Essentials course. Well done for sticking with it today and getting to grips with those ideas about aggregation, the new techniques of proportional circles and choropleth or filled maps, and unleashing the power of Alteryx for aggregation. Come back and join me next time when we'll take a look at how we deal with questions about proximity. What is near to what? And I hope not to have that cough next time. But until then, keep exploring and feel free to reach out to us here at the Information Lab for solutions to your data challenges. To stay up to date with all our YouTube content, hit the bell icon